Lesson 3-1, Write and Graph Inequalities. So in this video, we're going to review what an inequality is and learn how to write it in different notations and then be able to graph the inequality. So first off, let's look at some vocabulary. An inequality is just a statement that compares two expressions or quantities that may not be equal. So could it be equal? Yes, but it would also have like a range. So it might say less than or equal to, or greater than or equal to, or maybe it says it does not equal. A boundary point is just a point on a number line to determine the starting or the ending point of the solution set to an inequality. And we're going to look at that on a graph shortly. And then there's different ways to write them. You can the solutions, you can put it in interval notation. So in interval notation, you can use parentheses if the endpoints are not part of the solution, or you can use brackets if the endpoints are included. Now they could also be a combination of both. And then you have set builder notation, which uses braces and an inequality. So let's take a look at some examples here. Here are some graphs, and they also give you some notations here. So this first one here, you'll see that it has a endpoint here. It's a filled in. This one is filled in because 3 is part of the solution set, and the arrow is going to the right because it's greater than or equal to 3. And then right here, you can see we have our interval notation. Right here, they used a bracket because it can equal 3, and they have parentheses with the infinity sign because anytime it's infinity, you always use the parentheses because there's no ending point. The second example, there's an open circle here, and it's an open circle because it cannot equal 3. So 3 is not part of the solution set. So this one says x is greater than 3. And you'll notice in interval notation, they use parentheses on both sides. The third one, they have a filled in circle here at 6 because 6 is the biggest number it can be. So they say x is less than or equal to 6. So you have a parentheses on the left side because it goes to negative infinity all the way up to 6 with a bracket because 6 is part of it. And then the last one, you have an open circle at 6 because 6 is not part of the solution set. It's everything less than 6. And so in an interval notation, you have the parentheses used. So let's take a look at examples for ourselves. Here we want to write an inequality for each word sentence. Jamie's arcade game score is more than 1,200 points. So now we have to just choose a variable. And I usually choose a variable that's the same as what item I'm looking at. So the arcade game score. So I'm going to use G for game. So I'm going to put G here. It says is more than 1,200. So that means it cannot equal 1,200. So I'm going to put greater than 1,200. And that would be my inequality for that one. Next one, Miss Jones said each student's class party expense is to be a maximum of $15. So we're looking at expenses. So I'm going to use E. A maximum. That means it cannot go more than 15, but it can equal 15. So that means it has to be less than or equal to 15. Next, the temperature of Al's mixture in chemistry lab did not exceed 72. So if it didn't exceed it, it could get to 72. It just can't go past 72. So I'm going to use T for temperature, and it did not go past 72. So that means it has to be less than or equal to 72 degrees. And the last one, the carpeted area of the school library is less than 82 square feet. So I'm going to use A for area. It has to be less than 82 square feet. So those would be the inequalities based on these word sentences. Now we're going to take a look at some inequalities, and we're going to write it in another notation and then and then graph it. So here we just have a regular inequality. We want to put this in set builder notation. So set builder notation, we have braces, and then we would have the variable h such that h is less than 4. So the only thing different is we're just putting the braces and the such that part. Now to graph this, I would draw a number line. And now I'm just going to put the main number, and the main number is what they give me here. So I'm going to put 4 in the middle, and it says it has to be less than 4. So it cannot equal 4, so it's an open circle. Less than means less than goes to the left. So I have the arrow going to the left. Next, x such that x is greater than 16. So the other notation would just be this part right here. So x is greater than 16. So on a number line, I'm going to use the main number, which is 16. Since it can't equal it, it's going to be an open circle. Greater than means greater than is to the right, so the arrow is pointing to the right. This next one, I need to put this in set pillar notation, so I have my braces. And it would be W such that W is less than or equal to 190.5. And then on a number line, the main number is 190.5. Now, if you want to put more numbers on there, you may, but the main point is we want to see where that number is and where the solution would be based off of that number. So since it can equal it, I'm going to have a filled-in circle at 190.5. Has to be less than or equal to that one, so it has to go to the left. And our last few, here we have it. This is an interval notation. So we want to put this in a different set. Let's put this in set pillar notation. So this would be, I'm just going to use x such that x is an element of real. Or you could just say x is all real numbers. Now on a number line, I'm just going to be shading everything because it's every single number. Maybe I might put a 0 here, so you just know that it's every single number there. This one, 80, and so it has to be greater than or equal to 80. So this is the smallest side, and this is the biggest side. So if I put this in set pillar notation, this would be x such that x is greater than or equal to 80. And then if I put this in on a number line, I have this as 80. It can equal 80, so this is a filled-in circle at 80, and then it has to go to the right. Now I'm going to go back to a slide here, and I'm going to put these in interval notation instead of like the set pillar notation. So if it's h is less than 4, that means it cannot equal 4. So I'm going to have parentheses. It goes to negative infinity, and then the highest is 4, but it can't equal 4, so I use the parentheses. This one, x is greater than 16, so that means on the low end, it's going to be 16, but it cannot equal 16. That's the lowest number that can get around. And then the biggest number is positive infinity. We use parentheses. And this last one here, since it can equal 2, has to be less than. So that goes to less than to negative infinity. So parentheses there. But on the other side, it's 190.5. And we have to use a bracket because it can equal 190.5. So that is our lesson on writing and graphing inequalities.